Hey everyone, I intended this just to be some notes for y'all to look through, but I was requested to do a video on this, and I've got no problem with that. It just took me a little while to find some time to do it, but I will always try and go through something if anyone has questions. So, this is sum and difference of cubes. To start this lesson out, I went over the difference of squares and square of a sum. Difference of squares is something you should know. You've seen it all over the place, maybe x squared minus 9 breaks into x plus 3 and x minus 3. This is also a difference of squares, keyword being squares. 4x squared and 25, those are perfect squares. Square of a sum is more of just saying you have two terms being added together that you're going to square. And the most common mistake folks like to make is just squaring the terms like this. For example, some might say, okay, cool, this is 9x squared plus 16y squared. No, it is not. What you need to do is actually square them, duplicate them, distribute them. Some call it foiling. I don't like using that in later types of math because foiling only helps you with multiplying two terms by two terms. It doesn't help you with two terms by three terms or 3 by 3. What we're getting to today is the difference of cubes and sum of cubes. Now, instead of dealing with perfect squares like 4, 9, 16, 25, etc., we're dealing with perfect cubes. That would be 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3, 27, etc., etc. And there's a specific way we factor these. It may look a little confusing with the variables. That's why I wanted to give you all a lot of examples to go through. Example 1. 8m cubed minus 27. 8m cubed is a perfect cube, and so is 27. So your steps are right here. Step 1. There's a first set of parentheses you create. You take the cube root of both terms. There is no cube root on a calculator, though you could raise the number to the 1/3 power. I think that's a little time consuming when you could just remember the cube root of 8 is 2 and the cube root of 27 is 3. Notice I didn't put any symbols in here yet. Do not do that until the third step. Step 2 is creating this trinomial over here. All you do is square the first cube root, 2m, multiply the 2 together, 2m times 3, and square the second cube root. So again, this is from 2m squared. This is from multiplying both of those cube roots together. And this is from squaring the second term. That will always be how you create this second set of parentheses. Now let's talk symbols. I put an abbreviation here, SOAP. SOAP stands for, same as the beginning, opposite of the beginning, so plus in this case, and this third one will always be positive. The SOAP, SOAP. That is how you remember your symbols for this. I believe I have another example down here, but yes, these are the 3 steps you follow. And this is how you factor sum and difference of 2 perfect cubes. So let's go into more examples. All right, let me focus on this one first. 64x to the third minus 125. 125 might pop out to you. 5 times 5 times 5. 4 times 4 times 4 gets 64. So again, step 1. Take the cube root of both terms. So that's how I got my 4x and my 5. I did not put the symbols in yet because I really want to show y'all we're just dealing with the pure numbers at first. So this one goes here, this one goes here, cube roots. This first number, I said follow step 2 from above because this is 4x squared, this is 4x times 5, and this is 5 squared. Exact cut and paste steps every time. Now fill in the signs. S, same as the beginning. We started with a difference. O, opposite of the beginning. That is a plus. And AP, always positive. Let's look at this one here. This is a sum of 2 cubes. Same steps though. Cube root of both. Square the first one, 3a squared. Multiply the two together, 3a times 4, and square the last one. 4 times 4 being 16. Then fill in your symbols. Oop, come back. S. Same as what you started with. O. Opposite of what we started with. We started with a plus, now it's a minus. And AP always positive. If you're wondering, how the heck does this factor this? If you were to sit there and multiply these out, go old school distribution, 3a times all three of these, and 4 times all three of these, this is exactly what you would get. So this is kind of a technique that folks developed at some point to make it easier to factor these. You always follow these steps. So if you have gone through the notes, you'll know what the next part is. I drew some little squiggly lines. That way, if you're scrolling through the notes, you don't immediately scroll to the answers. If you haven't looked at the notes yet, I highly recommend that. This is the part in the video where I'm going to say, pause it, try these two for yourself, and then see if you got the correct answers. All right. Here we go. My first step's always, just fill in the numbers. Step 1, the cube root of both. I'll do one at a time. Cube root of 8v cubed and 27. Square 2v, this is 2v squared. This is 2v times 3 and 3 squared. The steps become, they're the exact same over and over. Excuse me. We got the same symbol, the opposite symbol, and always positive. You don't have to fill in the soap part. That's me just explaining the steps again. All right, so 2v plus 3 times v squared, 4v squared, excuse me, minus 6v plus 9. And over on the left, the right side, we have a difference. Now, 216 might seem like a large number, but realistically, just go ahead and sit there. You got 5 times 5 times 5. That's 125. Use a calculator. And then, oh, hey, 6 times 6 times 6 is 216. Bada bing, bada boom. Don't let the big numbers intimidate you. And yes, 1 is a perfect cube. Pro tip, 1 is a perfect everything. It's a perfect square, cube, fourth, fifth, etc. So if you see 1, that just made your job a lot easier because the cube root of 1 is 1. And 1 squared is 1. All right. Step 1, take the cube roots. Step 2, square each term, multiply them together to get the middle one. Same steps as before. So again, 6x is being squared. Don't just square the number, square the variable as well. 6x times 1 and 1 squared. Then fill in your symbols. Same as what you started with. Opposite of what you started with, and always positive. All right. Here are your homework problems, and the answers are just below. And I gave you a little hint for one of these. Check for the GCF. One of these does have a GCF that you do need to pull out first.